Okay. Now if you're copying down what I just wrote, stop copying and listen. Because this is going to be posted by this evening, by late afternoon. Okay? So we want to estimate the solution to the equation f of x equals 6. What do we mean by f of x equals 6? Well, what is f of x on this graph? Sorry?
No, it's the y.
Yeah. The graph is y equals f of x, right? Okay? F of x is a y value.
So 6.
You plug x into the f of x formula here. Here's the formula, right? So if I ask you to tell me what the solution to the equation is, well, y would have to be 6, right? Because y equals f of x. Okay? And you'd have all this equal to 6. Well, we're going to do that. We're going to solve that equation. But we're not going to do it yet. We're going to estimate it, again, just to see if our graph makes sense. Okay? See if our relabeling makes sense. So f of x equals 6 means f of x is the y value when we plug in x. Okay? To solve the equation, we need to find the x to plug in. So we get y equals 6. Okay? That is, we need to find the x value, or values, for y equals 6. Okay, well, where do you see y equals 6 on this graph? Oh, wait a minute, I didn't want to do y equals, no, I didn't want to do y equals 6. Since we haven't done it yet, I can change it without hurting anything. I wanted y equals 4. I was actually looking at the wrong labeling when I saw that. Okay, sorry. So now we want it when x equals 4, so I better change our 6 to 4. Y equals 4. Okay, so how are you going to do that?
We're going to have two x's because it hits the y or the
You're a step ahead of where everybody needs to be right now, but yes. Okay? So we'll pick up on that in a minute, and I'll ask you to say it again. But I want everybody to get through the step where we see what it should be on the graph. Okay? So, I mean, that's excellent. I mean, yeah, it's a great answer. But that's my next question. Okay. And you see it. You see it all. Okay, so I'm going to move along this graph, and I want you to tell me to stop when we get to a point where y equals 6. Okay? So I'm moving along the curve. You tell me to stop when I get to a point where x equals 6. I'm going to keep moving across the curve and back until somebody tells me to stop. No, don't anticipate. No, please. I want everybody to see this, okay? You're bypassing the step because you know. Okay?
No, you changed y to 4 and not 6.
Oh, you mean, I meant to say 4, yeah, okay. Yes, you want to tell me when y equals 4. I'm very slow to, my reflexes. Okay, yeah, okay, thank you. Yeah, what you got to say is, don't act like you're answering the question. You screwed up tone in your voice, so I know I screwed up, okay? That's all right. Okay. Or just say, hey, you screwed up. It's 4, not 6. Bonehead. Okay. That'll be fine. I'm used to it. Now, that was my nickname in high school.
Well,
Not that many people used it, you know. I mean, everybody knew that I was smarter than a lot of the class. So they got a kick out of calling me Bonehead. Because I made mistakes. And they loved it when I did. Okay. Plus, they were talking about stuff other than mathematics, and I was kind of bonehead with a lot of things. Okay, anyway. Ready? Tell me to stop when I get to the point where x equals 4. Not you. Because you already know. Okay, somebody else. You don't have to turn around. Just restrain yourself. Okay, ready?
Right there.
Here? Okay, well that would be good if we were using this labeling.
Oh, yeah.
Remember, we're using this labeling, so let's start over. But that was good, you're going to get it. Okay?
Maybe.
Ready?
Oh, right there.
Here?
A
Yeah,
little bit
actually, I was a little late, so I was probably here when you said that, right? Reflexes. Okay. Yeah, okay. So there's a point where x equals 4. Y equals 4, right? Okay? And down here, okay, let's see if there's another point.
Right there.
Yeah, right about here. And of course, we get those points by just drawing the line. This is the line where y equals 4. Y equals 4 everywhere on this line, right?
Yeah.
And where that line hits the graph is the graph points where y equals 4. So now, how do we find the x values? We've got to find the x so that y equals 4. Well, that should be pretty obvious. We just project down here and say the x coordinate of that point looks like about negative 2.7 or maybe negative 2.6, but I'll say get over here. There's 0.5. It's not quite halfway between 0.5 and 1, so I'm going to say it's about, what is this? This is 0. There's 1. This is 0.7. Okay? I'll put a little red circle around these. So, using projection lines, we estimate that when y equals 4, when x equals negative 2.7, and I'll write 0.7, okay? That is, these are the solutions of the equation f of x equals 4. Okay? Now, we could write out that equation. Okay, because f of x, y equals f of x is 2x plus 1 squared minus 2, which we reasoned out just by looking at the numbers. I say just by because it's a fairly complex procedure. But okay, so we see what y equals. If f of x, y equals f of x equals 4 then, is just the equation where 4 equals 2 times the quantity x plus 1 squared minus 2. How do we solve that equation? Well, we can add the same thing to both sides, subtract the same thing to both sides, multiply both sides, or divide both sides by the same number, non-zero number, because if we multiply or divide by 0, we lose all our information. Okay? So what do we want to do? What's the first operation? What do we do to both sides? First thing we want to do.
Subtract 4. Do we want 7 equal to 0?
Okay, we could do that. Because then we'd have this thing equal to 0. And then what would we do?
Quadratic formula.
Again?
Quadratic formula.
Well, we can't quite yet because we have to have it in the form ax squared plus bx plus c equals 0, right? So first we'd have to expand this and then simplify it so we'd have an a, a b, and a c, right? Well, we're going to do that. I'm going to do it easier. And then we'll do that. Okay? We're trying to find out x, right? Well, if I add 2 to both sides, I get 4 plus 2 equals 2 times x plus 1 quantity squared minus 2 plus 2, right? And negative 2 plus 2 is 0, so we're going to get, I'll reverse sides here because I think we're comfortable doing that. So that gives us 2 quantity x plus 1 squared equals 6, right? Okay? Now what are we going to do? Well, what I'm going to do is I'm going to divide by 2. Okay? Now that's 2 over 2 times x plus 1 squared over 1, and that equals 3, right? Because we don't use that C word thing, cancellation, okay? Because people do it wrong. Usually not in this case, but there's an epidemic of wrong cancellation. I've said it before, so I'm not permitting it. We have to see why the cancellation works before I'll permit it. Okay? So 2 over 2 is just 1. X plus 1 squared over 1 is just x plus 1 squared. That equals 3, so now we know that x plus 1 squared equals 3. Okay? Okay, if x plus 1 squared equals 3, what can we conclude? Well, if a square of a number equals something, then that number is plus or minus that something. Well, what number is being squared to get 3? What's getting squared here?
X plus 1.
X plus 1. So this tells us that x plus 1, and I'll put parentheses around it just because it might make things clearer, is plus or minus 3, right? So x plus 1 minus 1 equals plus or minus the square root of 3 minus 1. And 1 minus 1 is 0, so x equals -1 plus or minus the square root of 3. I didn't work this out in advance. Could have, because it was fairly simple. Okay? But I did an honest estimate over here, and despite the inaccuracy of my graph, I was right to 1 decimal place. Okay? The graph actually nailed it. I wasn't fudging. But if I'd have gotten 2.6, I wouldn't have been surprised. Okay? Okay. Well, square root of 3 is 1.732. Everybody knows that. At least everybody of my generation knows that. Everybody knew what the square root of 2 and square root of 3 were because we didn't have calculators, and they came up a lot. Okay? Nobody knows it now, but some people remember it from years ago. So everybody uses calculators instead of their heads, which is often necessary. If you ask me what the square root of 5 is to 3 significant figures, I can't tell you. Okay? So this is approximate, but it's to 3 decimal places. So that equals -2.732, or (07.32). Okay? And just to show you, one time when I got a good estimate out of one of my graphs, what were my estimates? -2.7, 0.7. Of course, I wrote them down here too, because I wanted to connect them to the graph. Okay? So, my graph says, when x is 4, according to the relabeled graph, I'm sorry, when y equals 4, according to the relabeled graph, the x should be 0.7, y should be -2.7. Okay? Should be able to do that. I'm going to give some equations to solve of similar nature. So make sure you incorporate that trick into your vocabulary. Okay? It's not a trick, it's the easiest way to solve a quadratic if you have it in factored form. Well, perfect square form. Incidentally, this form here is called the vertex form. They were the standard form of a quadratic. The ax squared plus bx plus c form is called the general form. Well, let's do it with the general form. Okay, so first, here's the equation. X plus 1 quantity squared means x plus 1 times x plus 1. X plus 1 times x plus 1 is x multiplied by x plus 1, bad x, I started to write a 1. That's the distributive law. X plus 1 times something is x times that something plus 1 times that something. It's not a bunch of little arcs that you draw on here. It's not a grid where you put the x and the 1 here and the x and the 1 here and do all that stuff. It's the distributive law, and this is the way it's written out. Okay, the other things are okay if I don't say differently. If I get it done, and I did the thing with the arcs, but I knew why. Okay? I don't want you to do the arcs unless you know why it works. At least if I ask. And then x times x plus 1 is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. So we get x and x gives us a 2x, we get this. And we end up with 2x squared plus 4x. And of course we have the 4 on the left-hand side at every step. That hasn't changed. So now we can subtract 4 from both sides. And then we don't go around rewriting what we just did. So this is equal to 4 minus 4. So the 2x squared plus 4x minus 4 equals 0. And now we can use the quadratic formula. And it's -4. Square root of 4 squared minus 4 times 2 times -4. All that divided by 2. Okay, that's 16. And that's 32. Yeah, that makes 40s. Looking cross-eyed or something. So we plug into the quadratic formula. Then we notice that 48 is 3 times 16. Okay? And 16 is a perfect square. So we can write this as the square root of 16 times the square root of 3 divided by 2, which is -4 plus or minus 4 times the square root of 3. It's not divided by 2.
No, it's divided by 4.
It's divided by 2 times 2. 2 times 2 is 4. So this equals -1 plus or minus the square root of 3. In other words, we just go through standard steps. We get the same thing we got over here. We have to because it's the same equation, just rearranged and solved using a formula, right? And my point is, you can watch the video if you don't get all that. Go ahead and copy it down. But this is less work and less arithmetic than this is. If you've got it in this form, this is the easier way to do the solution. Big point is, both ways, we see that the relabeling process gives us the function that we say it does. Okay? Because we do the algebra on the function we say it is, it agrees very well with estimates that we make from a good graph, even from a mediocre graph.